All right, it's unfortunate I couldn't squeeze the last little bit of that lesson in, but oh well, we can remember what we were doing when the bell rang. All right, so if I'm just finding a critical value, I can stop right there once I let it equal x. Let me do x equals. And we know that that's going to live inside the interval because we found that x-intercept and we set our windows to the x-min, x-max of the interval. Okay, now I have to use that value in my closed interval argument, right? I need to find f of -1 and then f of that number and then f of +1. When do you think we should use a rounded or a truncated number for a subsequent calculation? Never. If you can help it, the answer is never. So one of the things we'll be doing quite a bit of when we have these ugly decimals, which typically what we get when we have calculator work, is we're going to store them. So we got to report 3 decimals, but I want to store this now. So if you go back to the home screen, second mode, let's get rid of that. If you hit the X button, there it is. Okay, it always stores the X value from the grapher in X, and if you hit alpha 1, that's the Y, it also stores the Y value, just an FYI. But as soon as you go back to the graphing screen and do some other calculations, it's going to write over this. So it's constantly updating itself. We want to store this in something that doesn't have the risk of being overwritten. So here's what I'm going to do. Hit X and then stow right above the on button. And I'll use A, alpha A. It's right below the alpha button, alpha A. Okay, boom. So now it's in there. It's not going to get overwritten unless I manually do it myself. The other thing that you want to do is if you call it A on your calculator, you want to go ahead and call it A on your paper or iPad. All right, and so for an intermediate calculation, you can now refer to it as A. So I want to find f of -1. I want to find f of A. Okay, so after you report 3 decimals, call it A. Now to evaluate these, how am I going to do that? Well, I could just plug them in one at a time, but there's another way. We can, let's see, I'm going to turn this one off. That's the derivative, right? And I'm going to come down here to y2 now. In case I still need y1, I'm going to leave it in there, but turn it off graphically. I'm going to go ahead and type the original function in now. X e to the -x. And then -2x. Okay, so there it is. My original function is y2. Now maybe ideally if I'm doing the problem, I have these flipped. It makes more sense to have the function in y1 and its derivative in y2. But for what it's worth, I have the original function in y2. So now I go to the home screen, bless you, and I'm going to recall it, right? Alpha trace is your shortcut, bless you. I want to evaluate the function in y2 at the left endpoint, -1. So you do it like that. And we still need to report 3 decimals, -0.718. Now I do it for the critical value. So I'm just going to hit second enter. That recalls it. And now instead of -1, do we want to type in -0.374? No, we'll actually recall alpha A. Alpha A. So 0.204, 0.204. And that's how you then use stored values. So nothing is, you're not compounding your error by using rounded numbers. And then the last one is just at the right endpoint, which was at 1. And we get -1.632. And once you write those down to 3 decimals, now it's real easy. You just use the eyeball test, the inspection test. Which one of those is the maximum value on that closed interval? F of A. Good. So the maximum value is 0.204 at x equals. Now, if you did have to write a summative statement, you would say f has a max of 0.204 at x equals -0.374. So for a final answer, you would not put at x equals A. It's okay for like an intermediate thing. And which value is the minimum? Of course, it's the bottom. That's the absolute minimum value. Now, for what it's worth, since I do have the function in y2 and I have it turned off in y1, if I go ahead and change my x-min, y-min, y-max to something a little bigger, -10 to 10 is default, because I'm not interested in finding x-intercepts anymore. But if I still graph that function on the interval from -1 to 1, here's what the function looks like. Okay, so maybe the window was better when it wasn't -10 to 10. Let's do -3 to 3. All right, so there's what the original function looks like. So just inspecting it, you could tell that the minimum value is going to be at the right endpoint, yes? It looks the lowest. So if you hit trace and you type in a 1, of course, you get that value that we just wrote down. And you could also see that the absolute maximum is up here at the critical value. Okay, so you could verify that. If you're in trace mode, you could type in -0.375, since we know that value, and you get a visual. Does it appear to be at the top of the hill? Yeah. Now here's the way to find it on the calculator, which College Board would never design a question where you're able to answer a calculus question without calculus, okay, especially with the calculator. So second trace number 4, maximum, and then you could just scroll to the left of where you think it is, enter, scroll to the right of where you think it is, hit enter, and then guess. You can use the right endpoint, and it'll scan, and it'll give you the same number, okay? So that's like kind of cheating. Doesn't use calculus, right? But we confirmed what we got. Okay, I think that's pretty much 3.1. Any questions on that? 3.1. Good, bad, ugly, fun, boring? All of the above. Just mixed emotions.